Excuse me. Hello, hello. We're about to begin, not to delay John. Just two things. First, remember to send me the boarding passes. All Brazilians have to deliver the boarding passes for us to close the project later. And second, we had options here for the dinner tonight. The restaurant forgot to list vegetarian dishes, but they featured them. So if you're a vegetarian, just write vegetarian and we'll care for it. Not the British. The Brazilians have to deliver the boarding pass, please. It's really, really important. Otherwise, they'll ask you to refund the air tickets. I need the boarding pass of all Brazilians. No, you can send me an email if you did electronic check-in, or if you have it in paper, give it to Giovanni, please. So, John.
Seriously?
Okay, guys, we're up to the second keynote of the day. We've had the engineering aspect of renewables in the morning, and now we have social, user-centric approaches to just about the same problem, that of energy and a little bit wider of interaction with technology. I'm not going to spend more time introducing John because I understand he's got a slide about himself. So, welcome.
Thank you, Eleanor. Okay, so let's get started. Here's my, oh, it doesn't work, it doesn't work. Oh, press down. Human-computer interaction, you see. I'm expert in this. Who am I? So as I explained earlier, my area is human-computer interaction, and generally human-computer interaction has a focus on interface design. So it's about how people can use interfaces to get things done, basically. But kind of more broadly, I'm interested in activities and activity change, with the kind of idea that activity is often shared amongst people. It's mediated by computing resources, including interfaces that people work with. And when you produce technology, you can actually change the way that people do things and the way that they interact with each other. So I've kind of got a commitment to that as well. And obviously the focus is new kinds of computing and how you can change the nature of human activities through new kinds of computing. I think I've got a lot to get through, so I won't dwell too long on these examples of what I've done, but there's a kind of generic pattern, which is to take an ethnographically informed approach to understanding what's currently going on, to observe it, to ask questions about it, to kind of immerse myself in the culture, and then to try to develop some kind of requirements for a change to what systems are being used, or for a new system, and implement those things as prototypes and deploy them back in, and then analyze what the results are. So my current focus is domestic energy behavior, and it's the same kind of thing. It's about looking at how people understand energy behavior, what do they do around energy, what interfaces are they using, and what's the scope for kind of new kinds of interface and new information that people can use around energy, which is sort of what this talk is about. Microgrids, I don't think I need to kind of introduce microgrids because you guys know what microgrids are. Big issue for microgrids, and I think major reason why we're here is the idea that there's a need for education around microgrids, there's a need for energy literacy around microgrids, and the ability to control them and to conserve energy. And again, I'm not sure I really need to kind of sell this to you guys. You all know what the problem is, the global warming problem. So there is a real need to not only conserve energy, but also to find cleaner energy and to raise awareness about what is happening with energy, how much energy we're using, and kind of raise the profile of energy as an issue globally. Otherwise, we all kind of heat up and burn, you know. Yeah, so there's a need for kind of energy reduction generally. I don't think that microgrids is just about energy reduction. It's also about kind of finding new sources of energy and using energy in new ways as well. But there is also a kind of agenda about awareness leading to less usage, and this being a good thing. So, you know, there are different kind of solutions to the energy problem, and one of the solutions is to do with buildings, building differently, building more sustainably, retrofitting existing properties. That's a way of reducing energy. Also more sustainable appliance design. But kind of a big point is that energy is for people. People use energy. If there weren't any people, there wouldn't be energy use. So there's a whole issue about people needing to kind of own energy use. And the solution is a kind of a people solution, at least partly, about using less, using cleaner energy. And then the issue is kind of how to achieve that. Oh, my slide is gone funny formatted, but never mind. So this is about impact of behaviour. So I'm interested in energy behaviour, how people behave around energy, how they understand energy, how they try and control it, if at all. And here are some kind of stats about impact of behaviour on energy usage. So if you have two identical properties, for example, you can have big differences in the amount of energy that's being consumed, even if the occupancy pattern is the same. So you can have two apartments that are exactly the same occupancy pattern. You may have a small family in one, a small family in the other, and have a big difference in the energy consumption of each apartment. It's got nothing to do with the building, nothing to do with the systems, it's all to do with the behaviour, right? Now, one of our own studies showed a 5 times variation between two comparable properties. One was using 5x the energy of the other, and that's behaviour, right? So there's a need not only to build more sustainably, design systems that are more sustainable, but also to live more sustainably. And that, of course, involves this thing called behaviour change, and people in my kind of field, which is HCI/social science, you often see this phrase, behaviour change. And that will be a theme that runs through this. And the thing about energy behaviour is that it's about curtailment. There are two ways to think about energy behaviour, reduction and curtailment. So reduction is something about you buy solar panels, you buy something more energy efficient, and you put it on your property. And this saves energy. You use less energy, right? That's a reduction. There's also a curtailment, which is like giving something up or like losing weight. You know, you just have to be disciplined and save energy, and this is done on a voluntary or elective basis. And I think there's a debate about how much technology can do to help realise energy reductions. And there's, I think there was some mention this morning of smart buildings and smart grids. And obviously that's part of the solution, but it could be, especially in the UK, and that's a long way away. And so behaviour becomes very important, and curtailment becomes important as well. So what I'm going to talk about from here is work about understanding energy behaviour, work about engaging with occupants for that purpose, and particularly focusing on issues about control of energy and insight into energy through information design, designing information better so people can understand it better and act on it. So I'm going to give a review of approaches which is partly lip-based, and also look at our own research in Cogent Lab. And I'm going to also point out the implications as I go through for engaging current future microgrid end users in energy generation and usage control. So, I'm going to talk about a couple of projects. We've done a lot of work with social housing, working with occupants of social housing. Social housing is for the lowest income people in UK society. It's a big kind of demographic. These are properties with protected rents. There's a lot of legacy properties, but there's also interest in new builds and retrofits. And the social landlords of social housing associations have been tasked with decarbonising housing stock and other things like taking people out of fuel poverty through smarter housing, better designed housing. So I'm going to talk about two studies which are both around Coventry in the Midlands in the UK. A study of a new build development of passive house standard dwellings, and another study that I'm currently involved in, which is of legacy stock housing and retrofit, which is stuff from the 60s flats and a couple of 30s semis. Engaging with occupants, it's ethnographically informed stuff, which means kind of unstructured interviews, observations, being around people, seeing what they do, seeing what they say, stuff like that. And the whole purpose of this is to try to get a grip, try to get a handle on what real people in real life do to understand and control energy. So it's very kind of grounded in the reality of everyday life, to try to kind of generate accounts of what happens that can help us think about design work. So this is the first project I'm going to talk about. It's passive house development. There's a picture of it. It's in Coventry. It's around 20 properties that are mainly flats, but there are some houses as well. It has district heating, so the heating is shared across all the properties. It's got a big boiler room. That heating is locally controllable. The properties also have mechanical ventilation and heat recovery units. And so, you know, these properties should perform at a certain level. This project took place over several months, and there was a lot of face-to-face engagement, regular face-to-face engagement, you know, half an hour to an hour each time. So questionnaires delivered in person, so we would take a questionnaire and ask the questions in person, those things to establish occupancy pattern, establish an archetype in terms of type of occupant, look at awareness of energy use, and try and find out about people's priorities and motivations in terms of energy use. So here are some results. 84% people we talked to said it was very important to keep their energy costs down. 16% said that it's quite important, and 11%, they're non-exclusive, said it was ecologically important to reduce energy usage. So obviously the big thing for these guys is that it's financial. Energy is important because it's about money. Much less awareness of ecological issues. I guess it's no surprise these are some of the poorest people, lowest income people in UK society. Some of them may be in fuel poverty. Affordability of energy. So we asked about bills. 64%, this is an interesting finding, 64% said that they were happy with bills, but only 29% said they would have no trouble paying the bill, which is a strange finding, right? To say that you're happy with a bill, even though you can't afford to pay it. Interesting kind of finding, and that implies that you can have satisfaction expressed when a bill is in line, when a cost is in line with an expectation, right? But that doesn't imply that it's affordable. So it's a strange situation. And that, you know, if we talk about people being financially motivated, that money is the important issue, there could be a risk here, which is there isn't a motivation to reduce beyond a satisfaction level, which is an expectation about cost, right? So there's that confusion there between financial issues and personal priorities. So this is the kind of point really that grid electricity generates expectations about costs. And it seems that there's quite a big buy-in to those expectations. But they may not be consistent with what is personally affordable or desirable. So I think one of the big potentials for community microgrids is this thing about ownership. That if people own and control their own electricity supplies, this can lead to new sets of expectations and a form of empowerment. But I think that taking ownership of energy usage is by no means a kind of straightforward thing. Even if you put new energy technologies into people's homes, there's no guarantee that those things will be understood or taken up or adopted in meaningful ways. So I'm going to talk a bit more about that. Another thing we did was to ask occupants to estimate their own consumption. And the hypothesis of this is if you're aware of your own consumption, that means you're more likely to be in control of what energy you use. We did two things to do this, one was an appliance audit where we would look around the dwellings and see what appliances were there, and then ask these guys how much they think they're using them in time periods. And we also asked them to identify their own usage from a range. So we would show a range of properties and then what aggregate energy they were using, and they had to choose which one was theirs. Okay. So when identifying usage from a range, we found this data that 50% underestimate their usage, 31% estimated it correctly, and 19% overestimated it. Through an appliance audit, the accuracy went right down. So this kind of, the result here, I think it indicates pretty low awareness of generally about how much energy was being used. But if you've got a microgrid, it could be a community microgrid or just a microgrid, attached to your own property. I assume that you are running a microgrid to hit certain targets. You don't want to go back on grid. So this kind of implies that you need to be aware of how much energy is being used. So the next question is, why aren't people aware? But before I come on to that, just going to sort of turn left a bit and talk about controls. So we asked tenants to carry out tasks. So these were tasks with heating controls and MVHR controls. So here's the first one. We asked tenants to switch the heating on and then on, set the temperature to 22 degrees, and to set two 2-hour heating periods at specified times. Only one person out of 18 could perform the programming part of that, right? Number one was successfully performed by only 44%, which is to switch the heating off then on. And 2 was successfully performed by the same amount, to set the temperature to 22 degrees.
Quick question, did you incentivize them to actually carry the house?
Incentivize them to, no. Well, kind of. They in this study got something called Love to Shop vouchers, which are just, kind of like a money token. So you're right, there wasn't a real need for them to do this, right? But a thing that's frequently found is that people use thermostats as a switch, and we saw that as well, so that if it reaches a click point, that's what you use to warm your house up. So there was a thing that people kind of expressed that they understand controls and know the purpose of controls, but not necessarily how to use them. And you have complex interfaces to heating systems, as I'm sure most of you know. There can be a bit like a digital watch, and there's tons of mode changes, and there's nested menus in these things. You have to kind of know where you are and how to exit out of it. You have to know how to close off the sequence that you're involved in to execute it. So these are by no means simple interfaces. But an interesting thing is that when we did these tests with MVHRs, we got different results. So MVHR is mechanical ventilation and heat recovery, so it basically improves the air quality, and it can mitigate stratification in dwellings where it gets hot at the top because it's insulated, you know, so it can even out the temperature. Less need for window opening. So there's a kind of MVHR. So we ask people to do this stuff, switch it off and then on, reduce the airflow speed, set the MVHR to recirculate the air, or set it to clear the air out. Here are our results. Switch the system off then on, 34% success. Reduce the airflow speed, 50% success. Set the MVHR to recirculate air, 50% success. Set it to clear stuffiness, 44% success. Those results are out of 13, and there were 5 declines because they did not know that they had an MVHR in the house or the flat, and certainly didn't know where it was. The interesting thing that when we went through this is that tenants would ask us, have I done the right thing? What am I doing here? Am I doing this right? And ask for confirmation, like, did I do this right? So this suggests the converse of the heating controls. So you've got 2 things, heating controls, I know what it's for, but I don't know how to use it. MVHR, I don't know what it's for, but I can work out how to use it. So it's kind of symmetrical. So if you are going to try to promote sustainable energy behavior, you need both of those things. You need people to know what it's for and how to use it. Both things. So you've got to have occupant knowledge, what they're for, why use them, what's the purpose, and there's efficacy, which is that you know how to, right? And you need both. So efficacy leads us into issues about knowledge, but also usability. So it's somebody's got to know what the thing is for and why you use it and have a motivation, but also you have to have an interface that's comprehensible to be able to achieve that. So with the heating, we had high knowledge and low usability, so that adds up to low efficacy. The MVHR, it's the other way around, low knowledge, high usability, low efficacy. So the ability to take practical action around energy isn't straightforward. Given the current kind of state of controls that you often find in domestic housing. There's also a thing about satisficing, which, you know, so a thermostat as a switch is good enough. It gets the house warm, right? If the house is too hot, turn it down. And the next section is about that. It's about trying to improve efficacy through increasing knowledge, and so I'm going to talk about energy informatics. I'm just going to put my phone out because I don't know how I'm doing for time. Right, okay. That's the same slide. No? Yep, right, okay. So, energy informatics. So there's lots of interest in energy informatics in the UK, and I guess kind of more widely as well. And we're all used to kind of looking at stuff about smart meters. That's not the only kind of energy informatics. You can also have energy dashboards of different types, like web-based or app-based. This one is kind of typical. This shows you on your £2.35 per hour is what your comes from. I guess it's time feedback. direct feedback, it's understood by users. That's assumption number one. Assumption number two is that feedback is valued by users. And assumption number three is if people look at this stuff, they kind of understand it and go, right, oh yeah, so I'm using lots of energy at 8 p.m., so I guess, yeah, I need to reduce it, and I kind of know what to do to achieve that. But all of these things are assumptions. So there's a lot of literature about energy informatics. It's a big research area. Lots of interest politically in energy informatics through smart meters. But the success of energy informatics is argued about. There are some claims of no impact, that these things just don't change people's behavior at all. Other people argue that there are impacts. There's a great survey of smart meters by Sarah Darby at Oxford, where she shows that there can be consumption reductions of between 5 and 15% on the basis of informatics, and there can be some long-term impact. And this seems to say that energy informatics are important. You know, so they should be a research object. So here is a little study of user-centered design of energy informatics, which is the second study I was talking about. And this is research with more social housing tenants, two types of property, a block of 6 flats from the 60s, which are pretty shabby, being retrofitted, and a couple of semis from the 30s. These are both retrofit projects in which I was able to carry out occupant work at the same time. So again, it's the same kind of stuff, ethnographically informed, observational stuff, over a period of time, seeing people repeatedly, using various instruments to understand what's going on. The thing about energy informatics is we can give lots of different sorts of information in principle. So there can be aggregate energy, which is just energy as one chunk. You can give the aggregate energy in different time periods, time intervals. You can give costs. You can disaggregate energy. That in itself is a massive research area, as you probably know. By appliance, you can look at kilowatt hours. You can show stuff in real time or not. Yeah, and you can do this thing of showing graphics like bar charts and so on, or pie charts. Same kind of people in social housing, low income, financially motivated. Unsurprisingly, energy is important because it represents a cost. So the interesting thing about this one was that people aren't particularly concerned about the current cost. There is in fact a energy dashboard that you can plug onto your supply called current cost. And current cost, as its name implies, shows you what's the current energy draw. So it's you know, the energy you're using at this moment is going to cost you 60p. But people didn't seem to be concerned about that way of looking at cost. People want a regular figure, and they want to be able to depend on that regular figure. So is my energy going to cost me £10 this month, £10 next month, £10? I want it to be £10 all the way through the year, every month, right? Or every week. The important thing is that the figure should be the same so that you can plan for it. So there aren't any shocks in store. So, and it should be a figure that's the same regardless of seasonal variation in energy demand. This is what these guys wanted. Not informatics that show you what is currently being consumed. So, if we take that seriously, those kinds of findings, it means displaying that kind of information differently. So we've got to extrapolate from current use over long periods and extrapolate a regular figure. And the interesting thing is that tenants already try to work out what that regular figure is and are pretty clever at doing so. There we saw a saving behaviour where tenants would overpay in summer to save up for winter, and could often be quite accurate with that. So there's the ability to accurately estimate a figure. If my research is about one thing, it's about trying to understand what people actually do and what's actually important to people, try and leverage a design solution, and this is kind of one example of that. So people want cost projections, the ability to extrapolate from current and past usage, give a reliable periodic figure. And I guess again for microgrids, the issues are going to be similar. Energy projections and usage projections. Particularly if you've got a community arrangement where energy is shared, they kind of need to know what is your contribution to what's being used, things like that. And can you understand that as something regular and predictable? We also did this about running appliance quizzes to ask people to place appliances in energy bands, so high, mid or low consumers, which just means their wattage. What the high consumer is, the kind of one of the key meters, which are the things I just showed you that show what the current cost is, hence its name, and they show the current cost and current energy as a bar chart. And if you stick your kettle in the wall, it spikes. The bar goes up, right? So people are saying, oh dear, my kettle is costing me a fortune, right? But at the same time, you've got large TVs that are used continuously throughout the day and on standby all night, which don't spike. So they you can have lower wattage items, effective high, right? Higher wattage appliances that are effectively low consumers. And again, informatics, the current informatics don't tell you that stuff. So part of kind of becoming energy literate is to try to promote a better way that people nation and learn these things in accessible ways. Budgeting is another big thing, obviously. The thing about wanting a regular period, a regular figure over a period of time is about budgeting. A lot of tenants using prepayment meters. Again, this goes with the territory. People are low income. They're only eligible for a prepayment meter. That means they've got to pay their energy in advance. Now, that isn't a very desirable situation to be in. Prepayment meters are stigmatized. They aren't something that is generally available across the energy market. They tend to just be for lower income people that you can't offer them a direct debit, you know. So, but a great thing about prepayment meters is that they show how much credit you've got left. Very simply, in big numbers. So you put £10 on, it starts to reduce. You know, a day later it says £9.13. Day later it says £8.56. A day later it says £7.92. So there's a behaviour attached to this, which is this. Check the credit, top up the credit. Check the credit, and if it's going down too fast, target the perceived high consumers, which is going on, which is costing per day, because that's given by those informatics. And it's very, so people aren't that bothered about disaggregation. So there's a lot of research disaggregation. You about how much an appliance is used, energy readings, a lot of work in computer science. Immediate interest to tenants. And again, the question as to why is because they've never seen it's disaggregate. You know, so current use of energy informatics to support credit checking and infer a regular figure. That was the behaviour around prepayment meters. That supports budgeting, but there's a lack of information about what are effective high consumers, So you've got people worrying about kettles, where they have no need to worry about kettles, for example. Heating could be targeted as a way of reducing energy and saving money, but that may have undesirable effects in terms of comfort or even health. So, coming to some sort of requirements for energy informatics that come out of this, these findings we're talking about are sort of run counter to a lot of the assumptions in informatics design. So there's one requirement is for display, but not of current cost, not of current consumption, a regular. That's a big. It's a cost information. Priorities as a user. Price with lots of complications about what will realize the biggest saving in health, for example. Inferencing. So obviously, I think you kind of got the message from the previous slides that inferencing is important for energy behavior. These examples are of people making inferences to regular figures. And making inferences, again, about how much appliances save if they hit the big consumers. So if you base inferences on a current draw information, your inferences could be wrong. They could be fallacious. Okay? So we need to be able to project stuff about appliances, and that implies that the need to do disaggregation. Now, obviously, I'm in a lab with Eleanor and James and other guys from Cogent, and we've talked about disaggregation. Because I'm an HCI guy, human-computer interaction and behavior and all of this stuff, I don't really know what the problems are in disaggregation, but I'm told it's a really quite difficult problem. But one thing that could really be good about this collaboration is to try and bring these two sides of things together, if anybody is doing that kind of work. So yeah, this is what I just said. A kettle spike, that's the example of making a wrong inference. Right, my usage has spiked, so the kettle must be costing a lot. Inferences about high consumers and savings. If I turn this off, I'm going to save. Inferencing can also be supported by mobile informatics. So there's been some publishing around this, which is you have a simple little app which shows a bar chart. Again, it's time periods. And what you can do is carry this thing around your flat or your house and turn stuff off and see what happens to the bar. Right? Switch it back on again and see what happens. And so the whole idea, again, is to support inferencing. But in itself is very simple. However, the problem with that kind of thing is it only tells you what is the current draw. Okay? And what you really need to know is what is the impact for the amount of usage over time. So we've developed and deployed an initial version of an energy dashboard which makes use of the Cogent Haus sensing system. Now, James tomorrow is going to talk more about the Cogent Haus sensing system. This is sort of a major part of what Cogent does. We have about 120 deployments now. Eleanor will correct me if I'm wrong. Here it is, so it's just a bunch of energy monitors, and there's a server, and we have VOCs, humidity and temperature being measured. So these things were originally developed to do post-occupancy evaluation of buildings performance, and we've also used them to do pre- and post-evaluation of retrofits, see how the figures change, and they can measure these things, electricity usage, gas usage, as I say, temperature, humidity, CO2, VOCs. So we can use sensors to do these other things as well, not only to quantify energy usage, but also to map homes in terms of their comfort and be able to predict comfort. We can map them for heat and humidity. So we can start to think about quality of life, comfort and health, as well as energy usage through the sensing system. We can potentially infer behaviors. This is kind of ongoing work and debate. We can infer things like heating cycles or smoking or showering. Okay. So the idea is that we can use sensing data as a means of providing a constant feedback loop back to users, back to occupants. And so the important issue, as I'm saying, is how that data gets represented and what use people can make of it, and what's important to them, what are their priorities. We can put sensors into homes literally for years. I think in Cogent we would really like to see sensing systems become part of the build when a property goes up. You can get detailed time series data, you can get comprehensive pictures of performance over time, you can compare the same periods in different years, things like this. You can even track changes in behavior. So, you know, if the sensing shows different comfort patterns or different costs, you can kind of infer some stuff about behavior. Here is our energy report dashboard, which is very formative. It was put together by a really very, very clever undergraduate, but he didn't really get into the kind of stuff I've been talking about. So it's just a kind of first cut at an infrastructure, integrated back end and front end. And again, this is kind of one of the standard things that people do in energy, is to have a sensing system and create an interface. Here it is. So you can choose which things you're going to look at: electricity, gas, humidity, or temperature. You can choose when you want to look at it. You can select a time slot for updates because it's real time. You can select a unit of data, so your cost or carbon or kilowatt hours, and you can change your tariff so you get some accurate kind of cost information. This is kind of based on the idea of putting some credit on and watching this credit reduce over time. So instead of getting down on your knees and taking the washing up liquid out of the way to see your meter, you can just see it on a website. The usage statistics on this are not encouraging. We put a lot of work into user logging. So we have user accounts, we can work out where people have looked, what they've clicked on, and infer from that what's important in terms of what people are interacting with. And that was supposed to kind of leverage iterative design development. But as I say, the usage statistics are low. I think this particular interface is way too complicated, way too computer sciencey, and kind of breaks many design principles in human-computer interaction. So maybe I should have left that bit out, actually. It's a start, but we've got a kind of long way to go with it. So the kind of question is, what's the relevance of everything I've been talking about in terms of microgrids? What is it, how is this relevant to engaging end users in energy generation and usage control for microgrids? So I'll attempt to say something about that. So I suppose we can make the assumption that wherever energy is coming from, whether it's on-grid, off-grid, we still need to have some awareness of it, and we probably need to conserve it in some way. So it implies that people need to be motivated to do that people have to have the right information, and they have the right means of control, the ability to act effectively. An assumption of energy informatics is that, and it's also an assumption of our own design, is that people are motivated if they can see information in a useful form. Now I just want to kind of do another left turn and talk about a different approach which might be relevant, which is social norms. And this is the idea that people are motivated by the behavior of others. So what social norms does is show you your energy performance next to the performance of others. And they have to be comparable others, of course. So if you're going to compare your usage with somebody else, they've got to have the same kind of house and the same kind of occupancy pattern. And the notion here is that people want to conform to a norm. So if your neighbours are doing something, you want to be like the neighbours. That's kind of the simple idea. So if you're over that norm. The norm is just an average. You will come down. So here is a social norms implementation, which shows in green the usage of the person who's being shown this data. So let's say it's my usage. The orange line is the best, and the red line is the average. So this particular user is over the average at certain periods, which are here and here. And so the assumption is that, you know, somebody who's shown this will want to bring that usage down and may think about that usage. So it leverages social comparison. And social comparison is important because it may be a hook where there's no financial motivation and no ecological motivation. So the kind of settings that I've been talking about are money pressured. So the financial motivation is enormous. But there's a lot of people in society that have no financial need to save energy and don't particularly care about the environment either. So social norms might kind of address that constituency of people. But in microgrid communities, it might be a useful thing for people sharing energy to be able to compare their own usage with that of their neighbours. Again, this is contested. How successful this approach is contested. Here's a kind of experiment that used, you know, beautifully designed, massive number of homes, different conditions, showed that information on average consumption of comparable homes plus information about how to change energy use led to a 9% reduction for that condition. And that's interesting because it says that information on its own isn't enough. You have to have a means of action, the ability to act. So social motivation is not necessarily enough. You've got to know how to take the right action. And I think this can be supported, that the thing about action, that giving people the means to take control is a missing link in energy studies, energy behavior studies. And it's a surprising one because we talk in terms of energy behavior change, but the focus is not particularly on how people can act effectively. It's more about information. You know, as I've kind of implied, good design of information may lead to the ability to take action more effectively, but in itself it doesn't promote that kind of action. So there's lots of examples of implementation of social norms, and I've seen lots of nice work about community implementations. There was one in Brighton where I used to live where there was a street of houses called Tidy Street, and what they did was the researchers, it was a quiet residential street, very little traffic. What the researchers did was graph, draw data on the road with chalk. So what people would do is get up in the morning and look out of the door of the window and see where they were compared with their neighbours, and it was on the road. So this led to people discussing this thing with their neighbours in the street when they go out and bump into each other. So it's a nice kind of idea about using communities to leverage energy awareness. It's not something that I've looked at a lot, but maybe some of you guys have. So I'm kind of coming to an end. Where are we now in terms of energy behavior, energy informatics? It seems some interventions seem to work. There's claims about different interventions. Interventions just means, you know, you put in some new informatics or you do something differently that's different to the run of things. So you can put in some meters, you can try some social norms, you can put in some energy dashboard. But the results are often contested. It isn't like there's a solid finding on things where you put a particular type of informatics in and you can consistently claim it will lead to this reduction. There are always people arguing that there's kind of nothing happening as a result. Also, these kinds of studies are based on near-study measures. So you'll put an intervention in for a period of time, maybe 3 months, and then look at the bill that comes after. And then you compare the two bills. So they're near study, and you could say this is about novelty effects. So again, how do we get away from thinking about these things called interventions, which are a change to the norm, and have something that's more permanent, that's more embedded in people's lives? How does that happen? There's some very nice paper about behaviour that talks about dot, span, and path. Dot is a kind of blip of behaviour change. Span is a few months, and path is permanent. And they claim that there isn't any current study that can show path change. There isn't any study that can show consistent long-term permanent change. And a lot of the studies are about dot, they're near study. So it's another issue. So we need to have path change, and that means tracking behaviour over time. So that means that we need to have sensing systems in over very long periods, doing longitudinal studies. And just we need to know a lot more about this stuff. We need to know more about energy behaviour, what works for people, and the heterogeneity of people as well. People are different. Everybody's an energy user. We've looked at some of them, but it's a massive constituency of people, and it may not be a one-size-fits-all solution. So just some comments to finish off with. So there's a need to use less energy. I'm not so sure about Brazil, but it tends to be a policy priority rather than a concern of ordinary people. So the stuff about saving energy, being greener, and all the rest of it is coming from government. It's not coming from the ground, particularly. There may be some people who are interested in it. So it can be top down, and some of the studies suggest that I've done that people aren't, it's just not really on their map, they're not really bothered about it. So there's a need to kind of get away from this top-down thing and engage with what real people are doing and what their real priorities are right now in terms of energy, if any. Lots of writers, particularly around social practice theory, I think a few of you know about social practice theory, comment repeatedly about energy being something that's invisible. Right? It's just part of the furniture, it's part of your life, it's something in the background, you just never even think about it. Okay? And one of the things is that energy is not an activity. It supports activities, and the activity is the focus, not the energy use. When we talk about behavior change in other areas, like food disorders or drugs, those salience. So asking people to think and ownership to the energy problem, environment, technology. Behavior work talked about issues for usage control. Motivation can be low, awareness can also be low. Lack of information. At its worst, all you're getting is a bill every 3 months, or perhaps even worse than that, an online email that you never even look at. Otherwise, you've got a meter in a cupboard. Design of informatics, as I hope I've kind of put across a little bit, that the design of informatics makes assumptions, and those assumptions may not be borne out in people's behavior. There are also issues with designs of controls, as I hope I've kind of established. So usage has to be designed for, that's not grammatical, is it? It's my last sentence and it's not grammatical. How embarrassing. I think what I'm trying to say is that we need lots more on the ground, real studies of real people doing real stuff with energy. And it is badly needed to stop making assumptions, right? So this stuff that I presented today is just a kind of taste of way more work that needs to be done. We've got to design information that engages people, and we've got to design controls that makes action easy when they have a reason to act. Thank you.
Okay, guys, questions for John. We have all of 4 minutes.
Oops, overrun a bit.
So something I kind of
Yeah.
And that's my job, that's my research field. And I don't know, I have no clue how much energy I use there.
Yep.
And to control the thermostat, I had to find out what was the manual, download the manual, and I spent 2 hours to configure that just because I felt guilty. That's my research system, and I need to learn how to do that.
Yep.
So I don't know, it's something I keep thinking. Where we should start, or what sorts of community we should include. Is about engaging school,
Yep.
kids, neighborhood. I don't know if you have experienced something that gives you a hint about that.
Only kind of indirectly. I think the kind of link to education is through understanding what current behaviour and awareness is. And always strongly linking whatever solution you're envisaging to what you know empirically about where people are coming from. So what you've just said is that you are prepared, because you're the type of person that you are, to go and do detective work, to work that problem out, and some people are. So that could be an educational strategy, maybe. But other people, like people that I've been talking about, need much more simple, lean ways of doing things that doesn't require a lot of intellectual investment. But for sure, there are people that take a very intellectual approach to this, and that could be one educational way of doing things. But I wouldn't want to kind of prejudge it, because I think people are just so different. Yeah, so I don't have sort of clear answers to that, I'm afraid. Not at this stage.
Do you have any problems in terms of privacy? So the people sometimes quite concerned to keep their privacy for themselves without this money. There was someone talking for doing breakfast also about this, and then in principle everyone can access to your data and knowing about everything about you, but sometimes people are concerned, why should these people should know how many times I'm watching TV, for how long?
I know, yeah. I think that's a really, really good point, and I sometimes worry about the kind of ethics of what we're doing, and it can all seem a bit paternalistic, and we're just these academics that land in people's lives and try and find out stuff, and why are we there? So yeah, I kind of share some of those concerns. All I can say is that we don't use any information that people won't volunteer to give us. But yep, you're kind of if you're involved in social norm stuff, you're going to give your data away. Somebody's going to make use of it. It's going to be redisplayed to other people. So everybody's got to agree to that. People won't admit to fuel poverty. We've had a lot of trouble finding out about fuel poverty. So yeah, these kind of things are difficult, and they raise ethical issues as well. Again, I don't have kind of straight answers for that, apart from just be sensitive and respect people, which we all have to do with this work.
In terms of, let's say, some of your findings there to do with
Yep.
behavior and how they respond to social norms. I mean, these are additional tools that we have that are available to kind of tap into in order to influence people. Do you find it? I mean, how much of a barrier is there to incorporate things like that, that go slightly beyond the box than just sending information and informatics, let's say? What are the barriers to introducing that to engineers that are kind of, I don't know, working for E.ON or something like that, or to get it to this rolled out and take it seriously?
Well, I think the big six are already taking this stuff seriously, and their agenda is more about kind of quality of life and them being seen to offer a good service and being shown to be conscientious and conscious of global warming and things like that. The big six, well, I recently got a bill, and the bill said, John, you're using a lot less energy than your neighbours, congratulations. And I was like, whoa. And then it said, John, why don't you send us all your data? Tell us what you do. Tell us what your appliances are. What do you leave on most? So basically the big six are fishing for data. The claim that I'm using less than my neighbours doesn't really mean a lot. But it's interesting, isn't it, that if we could see more clearly where we fit in a kind of behavioural energy map or behavioural energy ecology, maybe that could have quite a big effect, you know. But I don't see any reason in principle why they couldn't roll it out, but I just think there's a lot of public apathy in the UK. Even me, I'm like, I'm not going to spend 15 minutes doing that for you. Which is shocking admission, isn't it?
I think it's very interesting what you're doing. I'm just interested that a lot of these, let's say, behavioral factors are kind of well known in other fields, like in marketing, and they're used to influence consumer behavior very readily in other fields. It's just that in energy, it's all very new, and we're not quite sure.
I'm not quite sure why. I agree with you. Yeah, and I personally think that energy is such a kind of broad, multidisciplinary area that, you know, you're mentioning marketing people, and it is extremely relevant. There aren't any marketing people here, I would assume. But yeah, we all need to start talking between disciplines, you know, as a matter of urgency.
Yeah, I think that you know, the answer should align into the long-term education, because, you know, changing people behaviors and sort of thing should be embedded into education. So I'm thinking that the current primary education should be changed, or at least that they should add one more subject called sustainability into to educate small children. You know, being aware of those things. Because, for example, that my son, who's 14 years old now, but, you know, whenever he boil water, put water into the kettle, he tends to put to the maximum level of water, and that's boiled while he just needs a cup of tea, for example. Yeah. But, you know, so many times I have to explain him that you don't need that much water. Yeah. But, you know, it's sort of thing. It's not only children, but as adults. I've seen a lot of adults, people, you know, taking those habits. So I think that for the long term, it should be embedded into education.
Well, I agree with you, but I think, you know, we can't get into this kind of paternalistic thing of saying this is what you should do. I just don't think that that's the right way to go. You've got to respect people and engage with where they are currently and what their priorities are, and try and leverage things that way. I think the thing that you just say, you've got to save the planet, so stop using so much electricity and all, it just doesn't work. You know, it's a kind of advice-driven approach that just doesn't work. We need something kind of more subtle, that's more engages with where people currently are, as I say. Because what I'm trying to do, I'm trying to dig out kind of how people think about it and what's the potential for extending their thinking about it. Rather than just say, you know, you've got to switch this off and don't use your TV so much. And why have you got a 60-inch TV? You know, because it can get very patronising, and I just find that kind of stuff not good, really. So we've got to think more about education, which is obviously one of the purposes of the workshop.
John, just moving back to the tech track. There is a phenomenon happening in Brazil that companies looking for automation and human interface interaction with these smart grids and smart homes, they only pay attention at the iPhone app. They often tell us, throw everything out, but keep that. That sells a lot. Yep. We all know that it's not the way. Is there a way to speed it up, to convince these leading companies that it's a waste of time to connect everything to your iPhone and move forward to something like what you present today?
Oh God, I don't know. That's a heck of a question.
It happening in the UK as well, that companies want to have everything controlled by the phone.
It's the way, you know, you monetize flipping behaviour change, and, you know, you try and find a kind of a opportunity out of that, which again is a bit. I don't know what the answer is. I said, well, you know, I'm supposed to be a mentor. I don't know the answers. That's why I'm here. I'm here to learn stuff. I don't know what the answer is.
When you are applying the social actions, it can be quite invasive. So you cannot force people doing what you think is right for them. But you can move from a social action to a market action, which means, just to give you an analogy, with cigarettes, I noticed, for example, that in UK are really, really expensive. And I quite smaller compared to, I would say, Italy, for example, where the cost of the cigarette is quite
Much
cheap.
lower, yeah, yeah.
In this way, if you are, I would say, introducing some taxes within a country for devices, appliances that are consuming a lot, is a different way to address the problem. So companies, they have all to develop something that is not consuming too much, or reduce the cost of the appliances in order to get it. Because because you cannot invade the privacy of the other people just because you think something is right. Like using less water in a cafe, just what I would not used to do in Germany. So but now I will pay attention about this.
What was there a question? No.
Well, it was just a comment.
Okay, right, yeah. Thank you very much. Thank you.